Hi, Hassler here. I'm going to do some notes for you on 8.2. We're going to be looking at transformations of parabolas. And so I just want to go back through and review with you what the parent function of a quadratic function looks like. If you recall, a parent function is the most basic of functions for any function family. And so the most basic of quadratic functions that we could have is y equals x squared, where that a, the coefficient of x squared, is 1, and then there is no middle term, no x term, and no constant. And typically, when we deal with this table of values, we pick numbers like -2, -1, 0, 1, and 2. If I were to substitute those into my function, I would be doing -2 squared. -2 times -2 is 4. Negative squared 1 is 1. 0, 1, and 4. And so we had talked last week about the idea that the vertex has the repeating y's, a pattern around it. And so 0, 0 is that vertex. I notice that the 1 and 1 repeat, the 4 and 4 repeat on either side. I'm going to go ahead and plot these points. And so I've got -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And always remember to connect your parabolas. So again, the vertex is 0, 0. By the way, an x-intercept is where I cross the x-axis or touch the x-axis. I am touching the x-axis right here at 0, 0. And so I have an x-intercept at 0, 0. And a y-intercept is where you cross or touch the y-axis. Again, I am touching or crossing the y-axis at 0, 0. So for the parent function, I get, again, the most basic of answers because it is the most basic of functions. All right. We've talked about vertical transformation or translations earlier in the year when we did lines. And so just a reminder that a vertical translation is a shift. It moves a function up or down. So shifts the parabola, because that's what we're talking about, right? Our graphs of quadratic functions. So shifts the parabola up or down. The general form that we will see for vertical translations is y equals x squared. That's that parent function, okay? And then in addition to that, I get this extra either plus or minus some number, some k value. And this k value, this number here is going to tell you the how many spaces, so how many spaces you move. How many spaces you move. And then, as we had said before, when we were doing lines, we had said that a plus means that you move up, and a minus means that you move down. Okay. So just like with lines, and if I recall, when we did lines, you guys did fairly well with these. And so let's just put that into practice with parabolas. Okay. So the first set of directions here say, given a quadratic equation, we're going to describe the translation, okay, compared to that parent function, and we're going to graph the function, and we're going to write the vertex. We have a couple of things that we have to do here, okay? All right, so it looks like I have this parent function, right? I have this parent function y equals x squared. That's my parent function. The extra is this plus 2, and that plus 2 tells me that I'm going to move up 2 compared to that parent function, okay? And so what I personally like to do is I like to get a little sketch of my parent function on here, just a quick -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And I just draw in a dash because this is not the new graph that they want graphed. This is the parent function. So this is my parent function. And then what I like to do is I like to look at each point on that parent function, and I like to count up to get to a new point. So if I start at this first point right here, I would count up 2, and that would be the new point on my parabola. If I look at this point right here, I count up 2. That's the new point on my parabola. If I check out the vertex and count up 2, right? I hope you get the idea. Take each point on that parent function, and I'm going to count up 2 until I get my new function, and this is the graph of the function y equals x squared plus 2. My vertex now has shifted, right? My vertex now is here, and that's at the point 0, 2, which hopefully makes sense. Instead of being at 0, 0, I'm now at 0, 2 because I've shifted up 2. I want you guys to take a moment, pause the video, and see if you can do problem 2, and then I'll have a check for you. Okay, so you should have recognized that the parent function is y equals x squared. That minus 4 means that we are shifting down 4. My vertex is 0, negative 4 as a result, because when you look at my blue graph that I have here, this blue graph that got graphed, every single point which moved down 4 from the parent function, and my new vertex then is here at 0, negative 4. Okay, so now we're going to go backwards, and this time I'm going to give you the graph of my new function, and we are going to determine what the function is. So we're given the graph, we're going to write the quadratic function. We're going to describe the translation that occurred compared to that parent function, and again, we're going to write the vertex. Let's see. I'm going to say that this new vertex, let's start with the vertex. This new vertex is here at 0, 1. In order to have a vertex of 0, 1, and again, you're always welcome to draw in that original parent function here. You can always sketch that in to have it, as a comparison. It looks to me like my vertex got shifted up by 1 unit. And so I'm going to say that my vertex was shifted up 1 in order to get to this new red graph. So as a result, my function is f of x equals, or y equals, the parent function x squared plus 1 because I was shifted up 1. All right, I'm going to pause the video and I'm going to have you guys give this a try on problem number 4. Pause with me. Okay, so what you should have noticed is that the vertex has been shifted down 5, putting my vertex at 0, negative 5. And because I've been shifted down 5, what that means is I'm going to have as my function f of x equals x squared, that's the parent function, subtract 5 to get the new function, the red function that is graphed. Okay, we're going to flip our paper over and we're going to have another video for the material on the back.